Yesterday you told to install the MPLAB IDE.
Have you installed that?
Yes, sir. I installed.
Okay. So let us inspect whether that installation is perfect. But I want you to up that IDE and then you share your screen so that we will try to create some sample projects and will validate whether the installation is perfect or not. Okay, now shall we
Okay,
check
sir.
that now?
It's taking some time, sir, to
Yeah,
open.
it will take some time for load. You are in parallel, you are installing another one, no? Like this one. Okay, let that, don't cancel it. Let that to complete. I think that is for 16-bit compiler or something like that. Anyhow, we are going to use 8-bit only. It's okay. Please install that, complete it, and then see.
Sir,
Yes, yes.
sir, yesterday you have told that you will be providing link for GCC compiler.
Yes, team. I believe we'll do that today. I think it's not a big deal.
Okay.
We'll do and configure it. Are you seeing my screen? Are you able to see my screen?
Yes.
Right now, here we have this source for distribution. Actually, it is like file distribution website. Just hit this download button. You will get a binary. But I don't know why there is no official website for this MinGW. Right. You will get the exe from there. Just download that. Just install it after downloading right now. I believe that is already downloaded. The binary is here.
Can you share the link, sir? Paste the link here.
Yes, yes, sure, sure. So it is here. That is the top. When you search in Google, they come as a top search option. Yeah, I shared it. After installing it, we have to do some config path setting that we will do once the installation is. Right here, we have different options, right? So you can choose. Otherwise, they won't install everything. Right. You can choose the first option, MinGW32 mark for installation. Right.
This one, sir?
Yes, but why it is not checking? And then GCC ADA. I believe you can ignore Fortran. Then you can go GCC G++.
Yes, sir. It's ticked now.
No, not that one. I believe your ADA is okay. The very after Fortran, we have GCC G++. That is important. And then the next one as well. I believe that's all. You can proceed. Get log. Apply changes. Okay.
Are you engineering graduate who want to kickstart your profession in automotive domain? Are automotive professional who want to switch your job to interesting positions with higher packages? Are you professional who look to work for great automotive OEM? Are you software professional who look for automotive job in Germany, France, UK, and US? Not sure about where to start? Then contact Yahasia Software for more details. They have nearly 20 years experience in corporate training and helped many professionals to achieve their dream job in automotive domain. They have students across 67 countries. They are conducting regular training on various topics. Automotive system testing using Python and embedded C for automotive are trending courses from them. Hence, to make your dream true, contact them now using 875-451-8745.
This is okay, right, sir? Now MPLAB.
I believe you can go for file and create a new projects. Go to file. Let this to install. I think they are doing TC plus. Object C, they are doing it, and then finally
It's taking some time, sir. This one.
yeah, it may take some time.
Can
Meanwhile, we can check this microchip stuff. Go to
yes, sir.
file and look for new projects.
Yes, sir.
See, when you select a new projects, they will show you this dialog box, right? So microchip embedded. So whether it is a pre-build or user Mac file projects, library project, we are going to create an application project. Select that one, right? After that, just hit next. Right, here we have to choose the family for which we are going to program. Right, here you can choose the family wise. We are going to use an 8-bit microcontroller. So it is PIC 16 mid-range 8-bit MCUs. One sec. On
This
PIC,
one, sir.
one sec. Baseline we have no mid-range PIC 10, 12, 16 MCP right now. Yeah, you can select that one. Right. After that, here you check whether you have, no, move down and look for PIC 16F877A. Controller is there in this list. 16F877A. Yeah, it is there. Yeah, select that. So you have to choose your device that for
Okay, sir.
which you are going to program, and then choose a simulation option. Simulator, yeah. Then next.
Why simulator, sir?
Simulator
Because
means, yeah, even the simulator means it is not like you are directly connected the IDE with the real microchip development board. You will develop the program in the PC first, and then we will transfer it to real hardware via flashing. So the code wise simulator and real hardware both same. So you can choose simulator. When you choose simulator, you can at least debug your code right now.
yes,
So
sir.
you have that facility. Then hit next. Okay, so it says XE8, which is a default compiler that will come when you install XIDE. So choose XE8 option, the next line, the branch. Yeah,
Okay.
that's it. After that, hit next. Then you have to specify a problem, that is project name. You can say a test project. This is right. That's it. Hit finish.
Sir, I have already installed this MPLAB, but I'm getting one of the errors, sir.
What error you are facing?
Sh- when I opened that MPLAB, it was showing no compilers found.
Maybe did you miss any installation step. Okay, let us see that in your desk. You can share yours.
Okay, okay.
Sir, now it's opened, right, sir? This one project.
Yeah, that's it. Here we can add source files right now by head whatever the C file that we are going to write now. That we
Okay.
will write in source file branch, select source file. Right there, you can right click and select new option and main.c.
Tired of complex GST calculations and messy stock management? There's a simpler way to run your business. Introducing the GST-based inventory and billing system from Yahasiya Software. This is the all-in-one software you've been waiting for. It automates your billing, tracks your inventory in real time, and produces accurate reports with just a few clicks. Spend less time on paperwork and more time growing your business. Do you want a demo? Call 875-451-8745 today, and grow your business to the next level.
Right, and then hit finish. Double click on that. So we have xc.h and then main right now. So now we are going to create two variables and then let us create two variables like int a, int b, and assign some value to them.
Yes, sir.
Now a equivalent to a plus b. So a will contain the sum of both.
Yes, sir.
So we have to get 13 as the result. Can we print it here? Will that work? If I use printf statement, will that work?
No, sir, because the header file is not included for printf.
Okay, you include header file and try. Okay, after that, brilliant. We have to say %d when we want to print the result, because if it is an integer, maybe you can say sum is %d, and then outside your quotes, you can pass your a and then terminate that line, right? It shows some error. Even after including it, it's showing error. Why? See, the printf statement that you use or a stdio that you use in our GCC is something different. You cannot use it in embedded C because here we are going to do program for a target platform. Our target platform is a PIC microcontroller. PIC microcontroller doesn't have any display connected with it. It doesn't even have a keyboard. If that is the case, this function we cannot use it with our microcontroller. The target platform for which we are programming, right? In that, this printf will not work because we don't have any display connected with PIC microcontroller. Yes, no, as we have in our motherboard or a laptop. In laptop, every laptop use a monitor. Right, this printf function will output this result in standard output device. For laptop, we have a standard output device monitor. What is the standard output device for PIC microcontroller? No, none. We don't have anything. What we can do? We can output this result to a port. Result to a port that we have right now. So we can use port D for output the result. Right. What you
Port
do?
port means, sir?
Port is like pins in microcontroller. Hardware pins, IO pins. Right. Totally in a microcontroller, you will have 40 pins. It depends on the microcontroller. The number of pins will vary. Even 8-pin microcontrollers are there. In our case, the Pikmin microcontroller that we chose while we create a project now, that is having totally 40 pins. In
Yes, sir.
that 40 pin, some of the pins are called as port D. They are called as port D. Port D means totally 8 pins will be there in that list. Let me show you where they are. I take control now, as of now. So that is the difference between an embedded C and then the common C that we use.
Okay, sir. So just we are like printing this output in the port.
Port.
We are
So that if
sending.
we connect some sort of LEDs there, the LEDs will glow.
நீங்க கம்ப்யூட்டர் எடை மேடை வைத்து தொழில் செய்பவராக இருந்தால் உங்களுக்குத்தான் இந்த வீடியோ. நீங்கள் பயன்படுத்தும் சாஃப்ட்வேர் பயன்படுத்த கடினமாக இருக்கிறதா? நீங்க எதிர்பார்க்கும் தகவல்களை பிரிண்ட் செய்ய முடியவில்லையா? நீங்கள் பயன்படுத்தும் சாஃப்ட்வேருக்கு அதிகமாக செலவிட வேண்டியுள்ளதா? நீங்கள் பயன்படுத்தும் சாஃப்ட்வேருக்கு சரியான வாடிக்கையாளர் சேவை கிடைக்கவில்லையா? சாஃப்ட்வேர் அடிக்கடி பழுதடைந்து விடுகிறதா? கவலையை விடுங்கள். உடனே யஹாசியா சாஃப்ட்வேருக்கு 8754187455 என்ற எண்ணை பயன்படுத்தி கால் செய்யுங்கள். அவர்கள் கம்ப்யூட்டர் சாஃப்ட்வேர் உருவாக்கத்தில் 20 வருட அனுபவம் உள்ளவர்கள். அவர்களின் சாஃப்ட்வேர்கள் சிறுகடைகள் முதல் அனல் மின் நிலையங்கள் வரை பயன்படுத்தப்படுகின்றன. சாஃப்ட்வேர் துறையில் புதுப்புது நுணுக்கங்களை புகுத்தி அதன் மூலம் பல்லாயிரக்கணக்கான வாடிக்கையாளர்களின் நம்பிக்கையை பெற்றவர்கள். அவர்களின் வெய்பேஸ்லைட் எனும் மென்பொருள் எடைமேடை வைத்திருப்பவர்களின் கல்வியறிவு மற்றும் கணினியறிவு ஆகியவற்றை கருத்தில் கொண்டு எளிமையாக பயன்படுத்தும் வண்ணம் உருவாக்கப்பட்டுள்ளது.
இன்னும் எதற்கு யோசிக்கிறீர்கள்? உடனே யஹாசியாவிற்கு கால் செய்யுங்கள். உங்கள் வணிகத்தினை மேம்படுத்துங்கள்.
Probably for 13 means 1101. 1101. Right. The total LEDs that you have, for example, if you have connected 8 LEDs to that port, right, only 3 LED will glow. The very first one, the second one will not glow, third and fourth will glow. That's all. Remaining will be in off state. Agree?
Yes, sir.
Right.
So it will be converted to the bits, and it will the output will be
Because the computer will process the information in binary, microcontroller will also do the same. When I assign that value to port D, it is a hardware register, which in turn mapped with pins. Based on the value that I store in that hardware register, according to that, the pin state will change. If I connected LED in those pins, only those LEDs will glow. So the port thing that I am talking about, right? So let me share my screen.
okay, sir.
Right here. Are you seeing my screen?
Yes, yes.
This is PIC16F877A, right? So if you look at that, 16F7XA, you can place any number here. So 77A also will come in this list. All
Not
have
able to see the screen, sir.
Oh. No, maybe you have to stop sharing yours.
I'll stop, sir.
You stop.
No, sir. I can see your screen. Pick 16F87XA.
Yeah.
Pin diagrams.
Let
that
me
pin
stop
diagram.
sharing it. And both of you are not sharing now. So I share it. What about Vikas? No.
Yes, sir. Now it's visible, sir.
Right now. See here, we have this RA0, RA1, RA2, RA3. This is called port A. You can ask me a question. Why they have a slash? That means that pin is multiplexed. If you make certain configuration, this pin 2 will work as a port A. If you make another configuration, the same pin 2 will work as an analog to digital converter input NOT. First input of analog to digital converter. Totally 8 inputs are there. So among them, this will become 1. So the pins are multiplexed. Based on the configuration that you make in some registers, you can utilize them as you like. Got it now? So this is RA0, RA1, RA2, RA3, RA4, RA5. This is port A. Then you have port C. RC0, RC1, RC2, RC3, RC4, RC5, RC6, RC7, port C. Then we have port B. RB0, RB1, RB2, RB4. Why like that? But problem here is why we don't have our port D pins here. Maybe I think I chose wrong pick. This is RC, RB, RA, 4 ports. RB, RC, RD. Where is port D? Only this is 28 pin controller. This is 40 pin controller. I am talking about this one.
Okay.
Right. In this, we have port D here. RD0, RD1, RD2, RD3, RD4. So when I store the value, the computed value that we have in the A to port D, based on the binary equivalent of that value, respective pin will set to high. Right. If you take 13 is the result. No, I believe 13 is the result. 13 means you go from the right. 1, 0, 0, 1.
Are you engineering graduate who want to kickstart your profession in automotive domain? Are automotive professional who want to switch your job to interesting positions with higher packages? Are you professional who look to work for great automotive OEM? Are you software professional who look for automotive job in Germany, France, UK, and US? Not sure about where to start? Then contact Yahasia Software for more details. They have nearly 20 years experience in corporate training and helped many professionals to achieve their dream job in automotive domain. They have students across 67 countries. They are conducting regular training on various topics. Automotive system testing using Python and embedded C for automotive are trending courses from them. Hence, to make your dream true, contact them now using 875-451-8745.
Remaining things are obviously 0. We are not going to talk about them. So only 4 bits. Among the 4 bits, this one will glow. 1, 0, 0, 1. 1, 0, 1, 1, 0, 0, 1 is C. That means 12. D means, sorry, 1, 1, 0, 1, 1, 0, 0 is C. D means 1, 1, 0, 1, right now. So in this, you start from this is RD not. This one will glow. And then that means this one will glow. And the next thing is second one will not glow. RD1 will not glow. RD3, RD2 and RD3 will glow. Right. Only this one will not glow. So RD0, RD1, RD3. These 3 LEDs will glow. Right now. That's how it is.
Can you repeat once again, sir?
See, this is the binary equivalent value. No, maybe if I am able to bookmark, that would be great. Let me check whether I am able to do. See, the result that we are getting after in your screen, When you add 8 plus 5, what is the result? 13. Agree?
Yes, sir.
Yes.
Right.
Yes.
That 13 has a binary value for 13 is 1100 because 1100 is a C, 1101 is a D. Agree or not?
Yes, sir.
Right. So here when we move this D to port, which port we are going to do? Port D. We are going to do very soon. So port D equivalent to, when I say 13, computer process the things in binary. So what they will do, they will accept this as a binary value. 13 will be represented as binary value, which is nothing but 1101. So when we give like that, your D naught is the first bit in port D. That will glow. D1 will not glow. D2 and D3 will glow. Right. So if you connect the LEDs in this RD0, RD1, RD2, RD3, only this one won't glow, other three will glow. Do you agree or not? So like that only we can validate our outputs. That should be some, so we have to create some symptom based on our result. If we get such a result, then our computation is correct. If it is a laptop, we see the number 13 directly in the screen. But we don't have such a display with PIC microcontroller. Then what is the solution that we have now? We can push that value to some port and can check whether that port has that value or not. Correct na? Clear?
Yes, sir.
Right.
Yes,
So
sir. Yes.
you got the point now. So now what you do? You have a program, right? Can you share your screen now? By default, as we chose PIC microcontroller, 16F PIC microcontroller, the register of that microcontrollers are available to us by default. We can just using the constant, we can access them. For port D, the variable to be used or word to be used is port D. Can you use port D in capital? Type port D in capital. You just comment that printf line. Right. Then port D. No, all are capital. Is equal to. The moment they have that register in that particular device, they will highlight that in green.
Tired of complex GST calculations and messy stock management? There's a simpler way to run your business. Introducing the GST-based inventory and billing system from Yahasiya Software. This is the all-in-one software you've been waiting for. It automates your billing, tracks your inventory in real time, and produces accurate reports with just a few clicks. Spend less time on paperwork and more time growing your business. Do you want a demo? Call 875-451-8745 today, and grow your business to the next level.
So you store A there and terminate the line. That's all. Now the program is ready. We have to check the program. How to check it? We don't know how to check it now. So let me tell you, there is a way. You click on line number 17. Click on line number 17 in the serial number. Yeah. So now you set a breakpoint. Right. After setting the breakpoint, we can do a debugging. Right. Go to debug. Go to debug menu. Right. There you have a option called debug main project.
Yes, sir.
So you got a debugger line or a cursor there. Now we do not know where they store A, where they store B. Right now. But at the end, they store the result in port D. Can we see the port D register? Can we monitor the port D register in MPLAB IDE? Yes, we can. For that, go to window, then check in window. So in that,
Target memory use.
yes, hit that one. There are two memories, right? Hit data memory is there or not?
E data
Target
memory.
memory views we have in that one sec. In that file register, hit on file register. Right. So this is file register. Again, go back to that window. There, if there is an again go to that memory. That means target memory views. There you find SFRs, special function register. Yes. Here we have address no INDF status, something like that. So
Yes,
there in that list, we also will have the address for port D. Move down. You
yes,
have port D, no?
yes, sir.
Yeah. There you have to get the result. What result? The 13 that we generated. In X, you may find D there. Now we have to do a step running in our program. Go to debug now. There you find a step for step running. There is a key press, maybe step into it is F1. You can press F8 in your keyboard so that they will do a step-by-step execution. Right. Press.
Now it is here, sir.
Yeah, again press it one more time. Now, did they updated the value in memory?
No, sir.
No, they didn't do that. I think they have to. Port D X value is 0. Run it in all one go. Again. So it is not updating, right? That value is not updating here. I think it should.
It's building, sir. It's taking time.
Actually, that they are looking to create. Okay, maybe let us wait for a while. Actually, once the X file is created, I think the steps that they are doing now is they are trying to build the X. Yes, now you got it. Look at that.
Yes, sir. Yes.
Right now. Maybe it's
Again,
some time. Refreshing time wise, it is having issues. Rerun the program now. No, check the breakpoint so that you will find the difference. So in embedded system, from this experiment, what we come to know is in embedded system has a limited resource. You have to, in order to verify your computations, whatever that you are doing, you have to use some of the available resource in that microcontroller to find out your result. Here we are in our general purpose programming, we are using this one monitor, PC monitor to see the result. But here we are using a port, particular port pins to see the result. But even here we are just using a simulation. In real, if you convert this a particular program to hex and flash it in our real microcontroller, those particular pins will go to different state based on the computation result. Right. That how can I verify that? I have to connect a LED in those pins. When my computation is correct, respective LEDs will glow. Do you understand what I am trying to say? Both of you.